Cool, thanks. Can you all hear me? There we go. Taylor just introduced me. I guess I'll introduce myself again. I'm Fidao on Twitter. I do serversforhackers.com, a site all about what programmers need to know about servers. Should actually set myself up. All right, so I call this talk server survival, but it's really just annoying things that you have to know about your server that I get a lot of questions on. So there's some seemingly simple stuff here. It's more complex than you think in some edge cases, or you get hung up on all this kind of random stuff that you don't think you should, right? And the next thing you know, you spent 6 hours figuring out permissions instead of actually doing work. I'm going to show you kind of a lot of stuff, but the point is to understand and not memorize a thing here. Just kind of, hopefully, understand what I'm talking about, or more pointedly, the concepts I'm going to talk about. So my semi-ridiculous chart of learning curves, in which any system administrator will be pissed off at me for saying that programming is harder than servers. I apologize, but I'm doing it. The point here really is programming stuff versus the mechanics of how to get stuff done on a server. So programming stuff, I'm talking about if you kind of get deep into a programming topic, perhaps programming for servers and like managing clusters and all the complicated stuff that goes into that. That can get really deep and really hard, and you have this kind of exponential learning curve where you might actually be learning things like math. So the server mechanics, on the other hand, is like what I'm talking about there is the stuff we need to do in our servers to get like an application up and running. And that is not any of this hard stuff, but there is kind of a lot-ish. So the learning curve of that is kind of a more linear, you kind of build on your knowledge and figure stuff out, but you're learning like how to accomplish one thing and that builds on another, but you're not going on this exponential learning curve where stuff is just stupidly complex. Now I don't know where I'm going anymore. All right, this is the fun part. Should I read this? I'm going to read this. There are no knowns. There are things we know we know. We also know there are known unknowns. That is to say, we know there are some things we know we do not know, but there are also unknown unknowns, the ones we don't know we don't know. Which is to say that when you are first staring at a server, that shit is scary. Like, I don't know what's going on. I remember turning on my first server. It was like on a stolen virtual box or a VMware thing I downloaded because stealing software was still cool then. I guess. I spun up an Ubuntu box. I didn't know what I was doing. I figured out how to install a lamp stack because there was a command that does it with one command. And then I tried to see what packages that installs, and there's a list of 50 or 60 things, and I didn't know what any of them were. And I was like, I have to learn this? This sucks. But it turns out it's easier. It's not too bad. That thing hides a lot of complexity, but that complexity was not as complex as I thought. We're all kind of reasonably intelligent that we know that there are unknown unknowns. So what I'm hoping to do in this talk is kind of reveal some of that so they become at least known unknowns. Or, known knowns would be cool too, but I only have an hour and a half. So annoying server things we're going to learn. I'm going to talk about security. That'll be the biggest subject here. That's actually going to be like 40 minutes of this talk or so. I'm sorry. And then supervision, network stuff, and permissions. And hopefully that will give you a good idea of some of the more annoying stuff, including how Forge is set up in specific ways to make your lives a little easier. Security, enjoying your new server responsibly. So we're going to just talk about, this is also, I'm just going to talk about like initial server setup type stuff. This is basic security. I'll go into what comes after that as well, so you have an idea of what you should or should not be scared of. Also, I'm going to use this quote again because this is also a scary part. I get a lot of questions on security, maybe some questions about what you should add on to Forge to make it more secure and that kind of stuff. My answer is that typically Forge does 99% of the stuff, and like you don't really have to worry too much. There is other stuff you may want to worry about, but it's totally up to you. But hopefully we'll reveal kind of the landscape of it. So protection, process, and compliance are the three subjects here. We're actually going to do protection for the most of it, despite it being the smallest on this scale or whatever. And then process and compliance, I'll kind of tell you what that is as I get to it. But we're going to start with protection of the things to do on your server when you get one. Cool, good. More JAWS themes for some reason. OK, so we almost all rent our servers. I'm sure that's an exception for some of you, but for the most part, we're on like DigitalOcean or AWS or Linode or something. We're renting servers, right? We're paying monthly, we're paying hourly. The servers are not ours. We do not have to worry about a physical machine, right? So security-wise, we don't care. Well, it's not that we don't care. We don't have to worry about someone walking up to a server, plugging in a keyboard, and getting access to a server, like being next to that server rack in New York or something. That's not our problem. So our problem is server access and network security, which server access is also kind of network security because you're accessing it. We're accessing our servers over a network. Of course, I left this behind. So we're going to worry about access and network security. So I'll kind of dive right in. The main tenets here are don't be user root, because root is dangerous. The root user can do almost anything, or pretty much anything, without needing a password or anything like that. So we don't want to be a root user, and we don't want to only use passwords for access. We want to use SSH keys, preferably SSH keys with passwords. So then you have an SSH key password and a user password. So how to do that? I'm showing you some commands here. Don't memorize it. This is all Googleable. I have it all on my website. But we're going to make a new user when we spin up a new server, right? So we're doing add user, Fideloper in this case. That means I'll have a new user, and that user won't be root. That second line here, this is specific to Ubuntu. I think my whole talk is specific to Ubuntu servers, so I apologize if you use other stuff. It'll be close enough if you are in a different situation. But anyway, I created a new user Fideloper, and then I add that user to this group sudo, which is a kind of magic setup that they have, and that lets that user use sudo commands. So I can do sudo service nginx stop or something like that. So I've made a new user that's not root. That user can use sudo. We should use that user as the admin user because that user has to put in a password to run sudo commands. You don't have direct access to user root, which would be dangerous because it doesn't need any permissions. So next thing on like your Macintosh or your workstation or something like that, you want to make an SSH key so you can access your remote server over SSH instead of just typing in a password for a user, right? So when you get a new email from your new DigitalOcean or Linode server, you typically get user root and a password, unless you have SSH keys set up ahead of time. But if you don't, then you're logging in over password. So what you want to do is create a new SSH key that you can use on your server. So this bottom command is run typically on your workstation, like your Macintosh laptop. So same command on the top there. We're just generating an SSH key. The second command here doesn't actually come with your Macintosh, but you can install it in Brew. But what it does is connects to your server and copies your SSH key, the public key specifically, to the remote server for the user you're logging in as. So what I'm doing is SSH copy ID. The -i flag is the identity file I want to use. So I created a file called ID whatever, and I want to copy the public key for ID whatever to the remote server. And specifically on the bottom here, it says it's added to the .sh authorized keys file for the user you logged in with. So notice I did not actually enforce in my server setup yet the use of SSH keys. You can actually still log in with a password because you're going to need that to copy your the SSH copy ID command so that later you can actually log into that user over SSH. To clarify that a little bit more, when you create an SSH key, you get two files. So the first is your SSH key. It's a private key. It should never be shared. The second is a public key, and that can be shared. And that public key is what you're copying to the remote server's authorized keys file for whatever user you want to log in with. So in this case, I can log in using this SSH key under user Fideloper. But I've only added it for user Fideloper. So that SSH key is not going to work for any other user that happens to be in that server. And you can put those on multiple users on the servers if you have a setup that, where you have like Bob has one user to log in with and Jane has another. Which is kind of like not really the case a lot in servers anymore because hopefully servers are being used as expendable and you kind of might just have one centralized kind of login system. All right, so we have created a user. We've created that user's SSH key. We've copied the user's SSH keys, or we've copied a local SSH key to the remote server for the user we want to log in with. This is now on the server, and we want to lock down SSH so that we can't, well, there's a few things going on here. So I'll go down the list. So the first, I'm editing etc ssh sshd config. The D is important because there's also an ssh config file in there. The sshd config is the one that edits the SSH server running on your remote host, on your remote server. This is the thing that allows you to log in over SSH to your server, the SSH daemon or however you want to pronounce it. So what we're going to do is edit the configuration for that so we can control how you can log into your server. So the very top thing is a port. The standard port for SSH is 22. I do not typically change that. That is sort of like a security through obscurity thing where you can change it to some other port, which makes a potential hacker or whatever have to guess what port your SSH port is open to if they want to try to log in. That can get sniffed out. It's not like a really good enough security thing. You might want to do it anyway. It's an added layer of something, but it's also very confusing. So if you're in a situation where you bring on like freelancers or something and they have to connect to your server, and it's not port 22, then whatever tool they're using might not know that, and they might not know they need to do another port. It's really just a pain. All right, so change port if you want. Permit root login is one of the most important lines here because you're saying, no, don't permit the root user to log in. And you're not letting them log in over SSH. So remember, if someone physically plugs into a server, that's not SSH. That is like your keyboard on your Macintosh. That's not an SSH connection. But since we have no control over the physical part for the most part, permit root login no is good enough. Now, if you decide to do without password, that will let a root user log in over SSH, but only with a SSH key. Password authentication, another important part of that, this disallows it, right? So we set that to no, which means the user has to have an SSH key to log in. Because I added an SSH key to the user Fidao, that's all set. That user can log in, and not with just a password. All right, the last part is kind of fun. I don't use these a lot, but you can. You can say allow groups, allow users, deny groups, deny users. Specifically, allow groups will let you define a user in a certain group that can log in. So if I have user Jane and user John, and they're both in group, the group name can be arbitrary, right? So if I have group can SSH, and both users are part of that group, I can say allow that group to log in to SSH, and no other group will be allowed to. Similarly, I can deny groups, or I can allow specific users, or I can deny specific users. So that's kind of just a fun thing to do. Or, you might want to use that if you have like a team setup and it makes sense to do that. After you make any changes, do sudo service SSH restart because otherwise changes don't take effect. All right, so that's user security, right? We have a new user that's not root. We have an SSH key for that user. That user has to log in over SSH. That user cannot use their password. They have to use their SSH key to log in. Note that your SSH key can have a password, which is not the user's password, right? So you can have two passwords. So if I log in and an SSH key that has a password, I have to put that password in. I'm then logged in. If I want to use sudo, I have to put my user's password in. So you have that kind of two levels of security to allow a user to run a sudo command. All right, so next, the network portion of security. Other than user access, we have the network stuff. This is basically just firewall. There is some more in how you allow programs to listen to networks. I'll get into that a little bit later. So firewall. The firewall, if you use Forge uses UFW, which is a wrapper around IP tables. I like knowing IP tables over the simpler tool UFW because you can inspect it. You can make more complex rules, and in cases where you don't have a simpler tool available to you, you can figure out what's going on. So sudo IP tables -L for list, -V for verbosity. You get a little more info out for the verbose output. This is an empty set of rules that you'll see on a new Ubuntu server. So three things going on. more things than that going on. The first thing I'll point out is that the default rule in every chain here, let me back up. There's 3 chains. There's the input, forward, and output chain. And I'll describe those, because I'll do that first. So the input chain is a little simplified, but the input chain in your IP tables rules will apply to any network traffic coming from outside the server and whose destination is inside the server. The output chain on the bottom here is the inverse for the most part. So any traffic originating inside your server, going outside of your server, will be affected by the output chain of the firewall rules. And then forward. Forward is kind of weird, and we won't even talk about it, but let's just, I'll just say that the forward chain applies to any network traffic that originates outside of your server and whose destination is not inside of your server. So if you think of a situation where a server might route traffic to another location, it originates somewhere else, it goes through this firewall, it gets routed somewhere, and its destination is somewhere else. That's like a NAT setup, which you might use in AWS if you have like a complicated private network setup. All right, so all 3 chains here have a default policy of accept. So if there's no rules defined, it will accept all of the traffic. If you set deny as a default policy, then any traffic coming in these 3 chains with no rules, they'll all get denied. And of course, that means your SSH connection as well, so you would never see the screen because you wouldn't be able to get in. All right, so we're going to set a few rules. And remember, don't memorize this, just understand what's going on. I'm going to add a few sets of rules to the IP table's input chain. We're just going to worry about outgoing traffic coming into the server. All right, so the first rule here is weird because I said the input chain is traffic that originates outside of your server going in, except now I'm setting a rule on the localhost network of the server, and nothing connects from externally into your localhost network. What the hell? Well, it's more like moving between networks in your server. So if I try to connect to, using a MySQL client to the localhost network to connect to my localhost MySQL, I might get blocked without this first rule by the input chain. So it's not just traffic coming from outside, there's a little more to it. This is kind of a boilerplate rule I just apply. I've actually have tried to Google a little more about it to figure out why you really need this rule. I've not found a good answer, but everything has it. Whatever. But I'm a professional. I know what I'm doing, right? I don't know. All right, sudo IP tables. The IP tables command is what we're going to use. We're going to do -A to append, so A for append, to the input chain. -I is the network interface, I for interface. Low is the name of the network. And I'll go over a little bit more of that in the networking section. But we're going to use a loopback network, which is what LO stands for, which is just your localhost network. So if you ever see loopback, it means your localhost network. And then we're going to jump the J to the accept target, which just means it's going to accept the traffic. So we're going to append a new rule to the input chain for the localhost network and accept any traffic coming from outside of the localhost network into the localhost network. God. It's simple, but whatever. All right, so next is the wonkier one, and it's by far the wonkiest rule of all the rules. But imagine a situation where you are logged into your server over SSH, and then you block SSH traffic, you're immediately screwed. So this rule you should do within your first set of rules. It's going to use a module. So with the -M flag there is for a module. It's going to use the connection tracking module. CT state, I think it's connection state. We're going to say we want any traffic that is established or related to that, but established. That means I have an SSH connection. I'm logged in over SSH. That is an established network connection to that server. So we're going to allow currently established connections, which means my current SSH session. Then you can go ahead and set up the rest of your rules and finally block stuff. So the top 3 rules here are pretty much identical, except we're allowing a certain port. So we're going to allow port 22, so we'll actually allow in SSH traffic. And then port 80 and 443 for web traffic, right? So web is port 80, SSL connections 443 by convention. If you do anything weird, like have a service listening on port 9000, then you can allow port 9000. right? So we're going to append to the input chain. -p is a new flag there. That's protocol, TCP. You can define UDP, or I think there's one or two other protocols. But since HTTP and SSH only go over TCP, we'll narrow that down to the TCP protocol. Port 22, port 80, 443. Finally, the last rule is drop. So there's no extra flags there, right? It's basically saying all other traffic, drop it, because we're not refining that filter by an interface or a port or a protocol. So I'm sorry if that's small, but you can see at the top, those are the rules we've created on the input chain. So we have the loopback one, the connection, the currently related and established connections for SSH, and then port 22, 80, 443, and drop. So any new network traffic coming into your server goes into the input chain. Any new network traffic that's outside going into the server goes through the input chain and goes through this list of rules. And the first rule that matches that traffic gets applied to it, and that's the only one that gets applied to it. So if I SSH in, if I connect over SSH, then that one third rule down is going to meet that, because it's a TCP connection over the SSH port 22, whose protocol is TCP, whose source is wherever, whose destination is wherever, or anywhere, to be more specific. Same thing with port 80 and 443. If I have web traffic, it'll hit the web one. If I have SSL web traffic, it won't. If it finally does not match anything else there, so say if we make a web request at port 9000 here, it doesn't match any of those rules, so it reaches the last one, which says anything else gets dropped. And that is how we protect our server from external network traffic coming in. Now notice that there's a source and destination setting here, right? So you could actually say specific IP addresses. So if you wanted to open up a server to talk to another one over MySQL, then you can open up a firewall rule whose source is the IP address of whatever server it's coming from, and who can connect to port 3306, the MySQL port, for example. So you can do defaults if you wanted to set the default to drop or reject traffic. I'm sorry, drop versus reject. So you can drop traffic. If you drop a traffic, something trying to connect that gets dropped doesn't know it got dropped, so it kind of just times out, which means waiting for whatever that timeout period is. If it gets rejected, it knows it's rejected and immediately will report back that it got rejected by the server. So whether you use one or the other is up to you. We see drop a lot in examples. Reject is kind of more polite, but drop might be giving away less information in that it's not like a protected port. I don't think that really matters. But anyway, the default policy, we can also change that to drop or reject in addition to accept. So if you wanted to set up some new rules, change the default policy to drop, then you can even get rid of this last rule because that's redundant at that point, right? It's going to get dropped anyway. Cool. So I defined port 22, port 80, port 443. But when we showed in the rules, when we looked in the rules, they actually had labels. They were labeled SSH, HTTP, HTTPS. If you check out your etc services file, this has that mapping of protocol and port to a name. So if you ever wonder why that is or where they exist, you can check out that file just to see kind of the mapping of names to network traffic. That's sort of just an aside. Firewall rules. So we set them up, but they don't persist through a reboot. So if your server reboots, they're gone. So you want to do something about that. Every server type has something to do about it. In Ubuntu and Debian, we can do IP tables persistent. We can install that package. Excuse me. That last command here, I think might not work in the latest Ubuntu anymore. I forget. I think it does. It might not. But you can do sudo persistent IP tables persistent save to save the newest rules. Or otherwise, if that doesn't work, you can do this stuff. You get this command, IP table save. It outputs text. That is just your IP tables rules. It saves it to a file if you redirect the output to a file. And then you can restore it from another command. If you save this in a specific spot, the IP tables persistent package will reload that in for you. So when you install IP tables persistent, it actually asks you if you want to save your current rule set. You say yes, and then it puts it in a spot, and then when your server reboots, it loads those IP table rules, so you don't lose that. I didn't at all talk about IPv4 versus IPv6. So we almost all still use IPv4, regular IP addresses. We'll have to someday use IPv6 because there's not enough IPv4 addresses in the world for all the networks in the world. So the only difference there is that we use IP6 tables command instead of IPv4. Everything else is really the same. Or I'm sorry, we don't use tables. We use IP6 tables if you want to worry about your IPv6 network. So if you spin up a server on DigitalOcean, it might say add an IPv6 network. If you choose to do that, you might want to make the same set of rules for that as well. Or you can just block it and just pretend IPv6 doesn't exist like we all do. Fail to ban. I want to mention fail to ban because it's simple and it's nice, but it also shows a little bit more about how IP tables works. So you can install fail to ban. This is going to monitor network connection attempts over SSH. It actually can do a lot of things, but by default, the first thing it does, the only thing it does out of the box, is monitor your audit, or I'm sorry, your, well, what log it monitors depends on the server. It monitors a log that logs connection attempts. If someone logs in too many times incorrectly, if it meets a threshold within a certain amount of seconds, it bans the IP address trying to connect. So if you install it and set it up, in our IP tables rules, we see something new. On the very bottom there's a new chain called fail to ban SSH. And at the top, we see SSH traffic, CSS multiport, D ports, SSH. So any incoming port whose destination port is the D port is SSH, so port 22, is going to get redirected to the fail to ban SSH chain, right? So we have a new chain. So any network traffic comes in, if it's port 22, it's going to go to the fail to ban chain. The fail to ban chain can have any number of rules depending on if anything's got banned. So this example sucks a little bit because I didn't get myself banned to test it out and take the screenshot. I guess I could have. But right now there's no rule. So it's just saying return to the previous spot, and then it goes down the rest of the list. If there are IP addresses that are blocked, then you'll see an IP address. You'll see a rule whose source is the IP address, and it says to drop or reject it. So you can see how you can jump down to targets and IP tables and get returned, which means you can set a pretty complex set of things. If you install UFW, for example, and check out your IP tables list, you'll see a huge, just bunch of crap, and it doesn't make any sense. It's hard to follow in there. So if you're using UFW, kind of just keep using it. But this is, it's a lot simpler not to, because you can kind of figure out how your traffic is getting routed through your firewall more easily when there's just less garbage in here. All right, so I didn't go over setting up an output chain. I almost never do, but you might want to set up blocking output traffic depending on your requirements. So maybe you only allow port 80 to leave a server if you're making like a curl request within PHP or something. One thing you might want to do is block like port 25 outgoing traffic. So if you have like a WordPress site and your WordPress site might get hacked and it might start sending emails over port 25, you can block outgoing traffic. Those are just some examples you might want to think about. Larry, I think this is the last-ish part of our server mechanics stuff. Oh God, I'm getting tweeted at. Timer. apt-get install unattended upgrades. So this is a way to have your server automatically install upgrades, but specifically we're just going to enable security upgrades. This is also on Forge, so if you've ever wondered about security packages getting pulled in, it's doing it for you. Sudo install, apt-get install unattended upgrades. In one file inside of this etc apt conf file, you can enable it by just saying unattended upgrades 1. In another file, also in the same directory, you can say this other stuff, which I think is already there by default. So you enable it. You say you only want security updates. That's the first one here, right? So unattended upgrade, allow origins. We're only allowing updates to packages that are marked as security-related packages. Install and shutdown. So if you want those installed and shut down rather than automatically, you set that to true. Automatic reboot is interesting. So this is, I typically keep it at false because you don't necessarily want your server rebooting when you don't know it's going to. Forge also sets this to false by default. So if you ever log in and you see your server needs a reboot, this is why you see that message. Unintended upgrades are on. It's installing security stuff. New packages are installed, and they recommend you reboot the server so the new changes get pulled in. If you want to do that with no downtime, you're looking at doing a more complex server setup where you have like a load balancer and multiple servers, and you can reboot them kind of in sequence so you don't lose any traffic. If it doesn't matter, if you can admit to yourself that your website does not actually have to be alive 24/7, then you can just go into your DigitalOcean server and reboot. OK, so that's like the mechanics. That's kind of 99% of what I do myself on most servers. There's more, but I don't want you to freak out about the fact that there's more. Like this is kind of like a lot of the actual mechanics of server stuff. Depending on where you work and your needs and all that stuff, there's a little bit more to a lot more. But that stuff is all kind of following the theme of access and restrictions and logging and that kind of thing, which I'll get into more of. So Linux and AppArmor are the two next things you might want to look at if you're looking for more. SE Linux, Security Enhanced Linux. Both of these systems, AppArmor and SE Linux, are kind of like meta tagging systems that let you have more fine-grained control over what stuff can do. So for example, can PHP run inside of Apache connect to MySQL over a network versus the localhost Unix file? More stuff I'll get into next. Or can Apache or PHP or whatever write to the disk? Even if you have permissions set to completely open, 077 or whatever you want to use, it still might fail because Linux is saying, no, sorry, Apache can't write to anywhere. So you can do that kind of thing. There's 2FA available for SSH if you want to. So you can add your Google Authenticator app and log in over SSH, and you have to add in a key. That sucks for when you automate stuff. So I don't know. Securing secrets is interesting. We have in PHP world this .env file for Laracon, for Laravel, yeah. But other systems use more complex things to get environment variables in, and securing that is sort of hard. But you might want to consider it, securing environment files through some kind of encryption or something fancy like etcd or console, these kind of things that exist to help you save data somewhere that can potentially be secured. That was a terrible explanation, I'm sorry. I'm moving on now, sorry. Strong password enforcement. I'll get into this a little bit more because next we're going to talk about process, and after that, compliance. Process is not like the things you do in your server to set stuff up. It's more so your policies at work or for your own sites or whatever of how you share information, right? So hacking nowadays is a lot of social stuff, phishing, whatever you want to call it. People calling up, people emailing your customer support saying things like, hey, I need access to this, I don't have access to it. I'm really, I work at your company, even though it's a complete lie, whatever. People find ways to get around your technical, server security by talking to humans, because, humans don't know anything. So in terms of access and secrets and passwords and whatever, your situation is at work, you might want to think about developing policies for how and what kind of information you're able to send people through your customer support or your email. It depends on your situation, of course. Similarly, you might want to define what happens when people quit or are fired or let go, whatever the situation is. Do you rotate SSH keys? Do you have a process to make sure they don't have access to stuff anymore? Do you care if they have access to stuff anymore? Oh, God, what? All right, just the inverse. What happens when people leave, right? Or I'm sorry, come. So you have a new employee. How do you onboard them in terms of security? So is there a shared space of SSH keys everyone uses? Does everyone have their own SSH key? All that kind of good stuff. Do you use like 1Password or something similar and share them in that? Do they get to see everything? How do you segment that? Those are all kind of like hardish questions. Key rotation is just when you invalidate an SSH key or just anything in general, any kind of access, and recreate it. Do you want to set up something to do that? Do you automate it? If you do automate it, are you willing to spend the time and the money it takes to do that? Because time is money, and to automate that and to do it right and test it and make sure you don't lock yourself out of stuff when you're rotating access. that costs money and time. So do you have that money and time? Do you want to do it? Auditing is fun. If you want to actually know what has happened on your network, you might want to set up auditing, which just means logging, essentially. For the most part, logging. So, are you going to pay for more infrastructure to send logs from all your servers somewhere? So like an elk stack, log stash sending to Elasticsearch, which stores all of the logs for some kind of event, which lets you then use Kibana or some kind of tool to graph that stuff, right? This was on my Servers for Hackers server, which is just a single server, but I kind of set up an elk stack on another server just for fun. For some reason, someone from this IP address sent 808, 807 or so requests that resulted in a 400 server error, some kind of access issue. Why did they do that? I have no idea. Like, what is this random traffic coming in my server at 3 p.m.? No idea. I didn't look at it any further, but if you need to, if you want to, you can start doing this and logging, access attempts and HTTP access logs and all that good stuff, and you can kind of see patterns of traffic and if there's anything you have to worry about in those patterns of traffic, like someone trying to gain access to something. All right, so compliance is the next part of this. Compliance is when you have to comply with someone else telling you what to do, like these guys. There's all these organizations that have compliance rules that make corporations feel better about your data being somewhere. HIPAA, high tech for health stuff, PCI for commerce and credit card storage, FERPA for education, and there's many, many more. These things require things like audits, things like paperwork. They might have actual security things beyond the basics. Some extra things you might hear are like SSL connections for encryption for data in motion. And then you might see things like the requirement for encryption of data at rest, which is data on your hard drive, or like how MySQL stores it, because MySQL can also encrypt data in addition to your hard drive data and all that kind of good stuff. So the big question of all of this stuff I've told you is how far do you want to go? I typically do what I showed you in the server mechanics stuff, and typically not a lot farther, but depending on your situation, you might need to go a lot further. You might want to go a little further. If you work at a company, if you own a company, if you're starting a company, having some policies about access and what happens when people come and go is definitely a good idea. If you can automate that, even better. But I think the 99% use case is just getting like your firewalls and your users set up and then letting it go. All right, we have a new topic finally. Whew. Good, messy. Supervision. This is supervising processes, which is to say making sure stuff is running on your server. So when your server boots, the Linux kernel does something that boots up, I don't know, does something. It starts a init system which has process ID 1, which basically initializes everything else. On our newer, most recent server editions of most server distributions, like Ubuntu, Debian, CentOS, Red Hat, whatever, we have systemd. And this, in turn, boots up everything else. So in this example, I'm showing you that we can see the status of SSH, the SSH daemon. But it's responsible for booting up almost literally everything. So if you install Nginx and PHP FPM and Apache or whatever, systemd or whatever the system has, older servers have something else, like Upstart or System 5, I believe it's called, then those are responsible instead. But we're looking at systemd. So that's going to spin up things like the network, SSH daemon, cron, all the good stuff, and then anything we install. So when you install a package like Nginx, you may not know it, but there is a configuration for systemd or something similar so that when you reboot your server, Nginx comes back up and starts. If Nginx fails due to an error, like a fatal error, then this is responsible for making sure it restarts. So systemd has some command, the systemctl command, and we can do the usual start status, restart, stop, and also has enable and disable. So you can actually enable and disable a service so that it doesn't start on boot, right? So if you disable Nginx, It removes a symlink somewhere, so a file is no longer in a certain location, and it doesn't try to load that when the system boots. Notice I use sudo service here instead of systemctl. The service command is a wrapper for not just systemd, but servers actually end up with multiple init systems because of legacy reasons. So some packages might still use something older, while newer packages that are updated might use whatever the latest is, right? So despite having systemd, you might have something still trying to throw configuration for a thing to boot up on server boot somewhere else. So the service is the command you should actually use for the most part, because it intelligently will call whatever system is appropriate. In this case, I'm doing sudo service ssh status. It forwards that to systemd, and I get this status. So if I did sudo systemctl ssh status, status ssh, because they're reversed, whatever. You'll get this, and it says it's loaded a specific file, and it says it's active. It gives a little bit about the process, and it shows the last few lines of the log, the appropriate log file for it, which is more than we used to get with other systems. Systemd kind of shows more output. It's kind of nicer that way. Let's look at the SSH service file. So this is not the most complex, but more complex than usual, than anything we'll probably write. But this is the configuration file that tells the server how to start SSH when the server boots. Let me read it here. So the first section is the unit section. This is technically called a unit file, even though it ends in .service. It has a description, which just says it's as an SSH secure shell server. After, we can say this has to start up after other things. So only start this SSH up after the network service, the target, is up. Only start it after audit D, the logging mechanism to log access attempts, has started. Then we have condition path exists, which is kind of neat. You can say if this file exists, don't start SSH. So you can just create that file if for some reason you don't want SSH to start up. If you log out and back in, then you're screwed. You won't be able to SSH back in. So don't do that unless you have a good reason, like having a local computer that you can plug into. Environment file, you can load in, or I'm sorry, we're in the service section, which is kind of the meat of it. The environment file, it just loads in a file for environment variables, so it has variables it can use. Exec start is the one to remember, if anything, because that is the command that this starts. It's starting SSHD. -D, I believe, is as a daemon, I'm not sure. And then it passes in some extra options that are an environment variable. Exec reload just says how to reload it. So if we do sudo service reload SSH, it sends a hup signal, which is a POSIX signal, which is typical for reloading a process. And the main PID, I guess it sends the process ID for some reason, specific to SSH. I don't know about kill mode process. I never Googled that. I don't know what that means. You can Google it. Restart and failure is an important one. It'll restart if SSH fails. So init process supervision both start stuff on the system boot and restarts it if it fails. Restart prevents exit status. Again, didn't Google, don't care. Type notify is what you'll use mostly. It's, I believe I did Google this one. I'm doing really good at this. So type notify, it's I believe how it notifies the system when it's shutting off or turning on or something like that. You can, we mostly don't use a lot of these, but you can find out if you want. So the install wanted by multi-user target. When a Linux system boots, it goes into different run levels. Multi-user is a higher run level that it gets to nearly last, where the system is ready to be connected and used by users and processed to be run and all that stuff. So we're saying to install this in the categorization multi-user so that it boots in the appropriate time. So it's going to both boot in the multi-user run level, but still only after networking and the audit D is turned on. Alias SSHD, that means I could actually type in sudo service SSHD status instead of just SSH status, so you can set up aliases. All right, more interestingly, how would we use this to do something like queuing in Laravel? This is how, and it's simpler. So the description can be whatever you want. I'm sorry, the file name. So put this in lib systemd system laravel.service, so you can Google that. You can see that in Service for Hackers. Don't memorize that. But I've named it laravel.service, and when I do commands, I'll do sudo service laravel start, stop, restart, whatever. I want to tell it to run is user and group forge. So let's pretend I'm running this on a new forge server on Ubuntu 16.04 that happens to have systemd. User and group forge, restart and failure, because we want it to restart if our queue throws an error and stops the queue. Working directory, you can say go cd into this directory first. Exec start, run artisan queue work daemon, and whatever flags you want to use. Once again, multi-user target, because we want this to be started on the appropriate run level kind of late in the initialization process when a server boots. And then you can just enable it. So we put it in this folder, systemd system. When you enable it, it creates a symlink to another location, and then it loads from that location. So you enable it, and then start it, and you can see the status of it if you'd like. Supervisor. Supervisor is one you might be more familiar with because we often install it, and we often use that instead to run our Laravel queues or our node applications or whatever. Notice that second command I have there after installing supervisor is, to start supervisor, but whatever. I thought I was going to say status. So systemctl start supervisor. The implication of this is that we are installing a process monitor called supervisor. Supervisor is being monitored by systemd, right? So you have this chain of stuff. Systemd is the main system, init system that boots up stuff. One of the things it's going to boot up is supervisor, and then supervisor is going to boot up whatever we tell it to. My only point in showing you that is to just know that you're adding more to your server. You're adding extra process supervising programs, and there is always already one on your server you can use. But this has more features, so a lot of times you can use it. I have no point in showing this slide other than to say that supervisor is running in systemd, like I just said. So if we want to create a similar configuration for a Laravel queue and supervisor, we can run, or we can create a configuration like this. A new location, etc supervisor conf.d, called it laraq.conf. Anything in .conf, ending in .conf is going to get loaded from that file, from that directory. And I create a queue here, right? So php artisan queue work is the command. The directory, so the working directory, we say auto start, auto restart. So start and boot, restart if it fails. Start retries is 3, so if it fails 3 times in a row, let it die. Redirect standard error to true. So anything that gets output to standard error is going to redirect to standard out. And then we set a log file for standard out. So what this basically just says is that everything output by this program, standard error or standard out, is going to get sent to this log file. User forge, you can set the group also, I believe. And one of the nicer features here is number of processes. So I can start 4 Laravel workers or whatever many you want. Whereas in systemd, it just starts 1. Like there isn't an option to say start up a bunch of these. So that is one nice feature. And there's other features you can explore in supervisor, which makes it nice to use. Forge, for anything it's setting up for you that runs in the background, is using supervisor. So if you know how to check supervisor and see the commands and restart them and all that stuff, then you kind of figure out how Forge is setting it up. And that's where you can look on your server if things are going wrong. So if you set up a queue worker, it's just basically setting up something like this, maybe a little more advanced. There's some extra options it does. And if we set up a daemon, then it's just using supervisor again to set up whatever command you want this to run. So it's just doing supervisor behind the scenes. That's all that's going on. All right. Now, yet another topic. Cool. OK, I'm checking the time. All right, so I'm going to go kind of quick through networking stuff. It's a big topic, and I will barely cover any of it. But it'll be some useful stuff. When you spin up a new server on DigitalOcean, Linode, AWS, whatever, you'll have networks that you can check. So the ifconfig here is a quick way to see what networks you have. This has 2. The first one is eth0. The second one is low. Remember when I talked about low in the firewall section, that's the loopback network interface. Localhost traffic is the localhost network. eth0 is the name of the other network we have, and that has an IP address, and that is the public IP address. Meaning that's the IP address that you can use to send requests, web requests, or whatever to the server. That's the one you use to connect to remotely. If you set up private networking, then you get another network. So eth0 is still the public network. eth1, in this case, is the private network with the 10.136 IP address. And that's the one you use to communicate amongst a group of servers in the same data center. Word of caution about private networks in your clouds, in your DigitalOcean, in your Linode cloud, the more basic ones. So things like AWS and Azure and whatever, this doesn't usually apply to. But private networks in your cheaper, I guess, clouds aren't really private, which is fun. It's not private to your account. It's not private to your specific account. So if I have a server in New York data center in DigitalOcean, and then Taylor spins up a server in New York and DigitalOcean, and we both have unprotected private networks, no firewall rules around them, then potentially we can communicate to each other's servers in that private network. So you want to set up firewall rules to make sure the private network isn't open to traffic you don't want it to be. This typically, the rules we set up before does that. Like we didn't define any specific network, like eth0, eth1, whatever. And so it traps all of it. But if you wanted to open up a private network, like if you have MySQL communicating in a private network from your app to your MySQL server, assuming they're two different servers, then you can set your source and destination port when you set up those firewall rules so they can communicate to each other. Cool, okay, sockets. We have two types of sockets. You might be familiar with this by playing with Nginx. A TCP socket is the combination of an IP address and a port. The end. A Unix socket is a file, and it does the same thing. It lets you send data back and forth. It's a faux file, F-A-U-X, faux, in that it's a file in certain parts of Linux, but it's not really a file. But the fun part is that it's subject to file permissions. So as a user, as a group, and it has permissions of whether a user group or other can read, write, or execute. And of course, it's only available to local other things on that same server because it's a file on that server. TCP network, TCP sockets work over the network and potentially can be communicated to, from other servers. Nginx, for example. On the top thing here, we're saying listen on port 80 on IPv4 and IPv6 networks. So listen on port 80, we don't define an IP address, right? It's just the port. It's binding to all networks on the server, right? So this is saying if I have this server as a private network, bind to eth0, bind to eth1, bind to low, the loopback network interface, bind to everything on port 80. And then if you want to check that out, you can run this netstat command that, and then I search for the word HTTP. You can see it's listening on HTTP on star colon HTTP. So that basically means star is all networks, colon HTTP, HTTP, and HTTPS are port 80 and 4043. This is using that stuff from Etsy services where it names a network, as a combination of port and protocol. So HTTP, which is TCP port 80, HTTPS, TCP 443, listening on all networks. So the important thing here is it has stars. The stars mean all networks. If we configure Nginx to only listen on localhost port 80, then we can only access that by making a curl request or something within our server to localhost port 80. So this is a useless website, right? You can only access it within your server. Why would you ever want to do that? I don't know. Unix socket. So we'll talk about MySQL. We'll learn some stuff about MySQL and also see Unix sockets. MySQL, when it starts up, creates a Unix socket. So when you connect to it on your MySQL server and you say connect to localhost, or if you define no host, which is just defaults to this, it's going to connect to MySQL and it's going to communicate through the Unix socket. But we'll also see that it has bind address, and then it connects to localhost, the TCP socket. And it's going to bind to port 3306. So we don't see the port in this socket, but we just see the network address. But rest assured, it's connecting or listening on a TCP socket at localhost port 3306. This is very specific to MySQL. But localhost is not localhost, which doesn't make sense. Localhost is not 127.0.0.1. So if you connect over localhost, you're connecting on the Unix socket. If you connect by IP address localhost, you're on the TCP socket. I hope this makes sense. So let's say I don't bind to the localhost network, right? I'm not binding, I'm not listening, if I'm MySQL, to port to address 127.0.0.1, right? So let's pretend in this case I bound MySQL to the private network IP address. Maybe I want to connect another server. Maybe I want another server to connect to this MySQL server over my private network. So then I have to bind it to the private network so that it's listening on that private network. If I then connect over localhost, I can, because it's not using that private network, right? It's connecting through a Unix socket. And of course, I'm assuming I'm within the MySQL server here. I'm not on a remote one. But if I connect to 127.0.0.7, it won't let me because it's no longer listening on the TCP network 127.0.0.1. Can't connect to my SQL server. It's not saying it's not allowed. It's saying can't connect because it's not listening there anymore. OK. Now I will try to connect to it over the localhost network. I'm sorry, over the private network that it is listening on. And I get a different error message. It's still not letting me, which is frustrating, but we'll see why. But this time, it does not say can't connect like it did here. It says it's not allowed to connect, which means MySQL is blocking it, it's not just the network level stuff. So you create a new user. You say that user is allowed to connect on that network, because that's how users work in MySQL. Users in MySQL have a username, a password, and a host that they are allowed to connect from. So I'm saying this user can connect from the private network, and it happens to be connecting to the same private network. So when I retry that command in the bottom, it's going to work this time because I said it can. So what's going on there is MySQL is listening on the private network, and I'm trying to connect to it. It can't. I have to make a user that it's allowed to connect with, and then it works because it's listening on that network. OK, normally localhost is 127.0.0.1. That's defined in your etc host file, usually where the host name localhost will actually resolve to the TCP network. But MySQL is special and has a Unix socket. A review slide. I made one. OK, this is what we talked about. We talked about how you can find your networks with the ifconfig command. We talked about learning the socket types, TCP versus Unix. Unix sockets, remember, have permissions, so it's possible that stuff trying to communicate with it doesn't have permission to, based on user group, other read, write, execute stuff. We'll talk about that. We saw an example of MySQL, and the next section, yeah, permissions. So we're going to talk about this. I think I froze it. Good, permissions. All right. Permissions is this thing that's easy, except it sucks completely, and you always hit against it, and it causes hours of your life to disappear. So let's talk about permissions, and then we'll also see how Forge uses it to make stuff a little easier for us. OK, God, permissions. So who are the actors in Unix that can do stuff on things? Very descriptive. In Unix, we have users, groups, and others. So a file or directory can be owned by a user and can be assigned a group, and it can define how anyone else can do stuff. Right, so a user can own a file or a directory. And then we have group permissions, which are kind of shared permissions. So if user Jane and user Joe both have group admin, excuse me, we can say this directory can be edited by people in group admin. So Jane and Joe both can edit that. Other is anything else. So if it's not the user, if it's not an assigned group, then it's other, it's someone else. User group and other can individually be set to whether or not a user group or other can read, write, or execute. Reading a file is kind of easy to understand. It's just reading what's in the file. Reading a directory means you can list out what's inside of the directory. Writing, you can write to a file. If you can write to a directory, you can create new files in it, and I think delete the file or directory. Execute, if you have a file that is executable, it can be executed as a command. If you have a directory that is executable, it means you can cd into it. If it has no execute permissions, you cannot cd into it. OK, so at the top here, we're using chown to change owner. And let's just pretend for the var dub example.com directory, I'm going to change the owner and group to data. Notice they're separated by a colon there. That lets you change the owner and the group all in this one command. So I will change the owner and group of this directory, because you can. But then I'll actually do chmod to change the mode of the directory. And I'm doing it in 3 ways. The -r flag is recursive in all cases here. The second command down here, where I'm chmodding ugo, I'm explicitly setting the read, write, and execute permissions for the user, for the group, and for the other. So g equals read, write, execute. U equals read, write, execute. So the user can read, write, and execute. The group is only allowed to read and execute. Other is only allowed to read and execute. If you want to shorten that a little more, then you go down to your third line, where you say user equals read, write, execute, and group other, so go, equals rx, meaning group and other can read and execute. Notice what I'm not doing here. I'm not using any of those stupid numbers, because what the hell do they mean? Like, please remember that you can do this instead. It makes so much more sense. OK, and then you can do these kind of relatively, where on the bottom here, I'm adding or subtracting permissions. So despite whatever the current permissions are for user and group, I'm adding the execute permission. Despite whatever the current permissions are, I'm removing the execute permission. And you can comma separate your various rules here. So on the bottom, I also did that in the artisan command. So what we're basically saying is that user and group can execute the artisan command, other cannot. All right, so we have this output when we list out a directory. What the hell does that mean? And it tells us stuff, if you know what to look for. The first letter will say a few things. D means it's a directory. It might be L for a symlink. It might be just a dash for a file. It might be S if it's a Unix socket. And there might be others, I don't know. But we can see this example, this is a directory, because D is the first letter there. And then read, and then user, group, and other. So we have 9 letters next to it. They're not really separated at all. You just kind of have to know that the first 3 are user, the second 3 are group, the third 3 are other. So user and group, user can read or execute, group can read and execute, other can read and execute. That's how you read that stupid line of X's and R's and W's. Dash means it's a file, and otherwise this happens to have the same permissions, this composer file. So anyone can execute this composer command. Only the user could edit it, even though I think it's like a binary that you can't actually edit it. But you could open it in Vim or something and see it. I have changed the permissions of this directory, this example.com directory, to be owned by deploy, but be part of part of group www.data. So how do we see the commands for that, or how do we see the permissions? So it's a directory, and then we can see user can read, write, and execute, and group can read, write, and execute. So user deploy could deploy new files over these because it's allowed to read, write, and execute over them. Similarly, anyone in group www.data can do that as well, because the group permissions are set that way. So even if you're not user deploy, if you're Jane in part of group www.data, you can also edit these files because we have the right permissions. Right with a W, RWX. Oh God, I had to Google this command. OK, so we're listing out processes with the PS command. And in this case, I'm doing things. I don't know what AXF is. I don't remember. O is the output, and I'm telling it what to output for specific processes. So I'm saying, show me the process ID. That's what PID means. The user, group, and the command. And then I'm searching for either Nginx or PHP. So what are we seeing here? Processes also are run as a user and group. So Nginx and PHP are set, in this case, as www.data is all we really care about. So Nginx and PHP both have a master process. You need these to start as user root because it has to do things that privileged users need to do, like bind to port 80, write to log files in the var log directory that is usually owned by user root. and do other things. But once it sets itself up, it spawns child processes, and it de-escalates the permissions of those spawned children processes by setting their user and group as something else. So by default, in Ubuntu and Debian servers, we see the spawned child processes of both Nginx and PHP created as www-data for the user and group. That means Nginx, well, it gets complicated. Ooh, and there's a spider. I don't know. I mean, I did just kill something, so what are you clapping at? Okay, so a process is run as a user and group. That means it needs to have permission to write to a file or directory somewhere. So if PHP is run as user and group www-data, and it tries to write a new log file or cache file by like a user or forge or something like that, for example, it might not have permission to unless that other bit says that, you know, user group forge can, or says anyone can, because that's the other bit. It's just anyone else. Did I just go backwards? No, I didn't. Good. So this part, I have a directory owned by deploy and group www-data. If I run this PHP in a web request through PHP FPM, it's going to be able to write to a new file in the example.com directory because the group www-data is able to write to it. All right, so if a directory and file is owned by www-data, try to run commands as www-data. You'll run into less issues if you run like artisan as user www-data, this is how you can. Sudo is not just to escalate yourself to user root. You can escalate yourself to any user. I don't know if that's escalating anymore, but you're changing. So I'm running this foobar artisan command as user www-data in this case. Let's see a little bit of how forge works. Whoops, give me the time. Oh boy, okay. All right, why does forge just work for permissions? Hopefully it just works for you, depending on your setup, you know, but for a typical Laravel site, it does. Forge is set up so that when you add an application, the files are added to the forge user's home directory, right? So we see the home directory, that's the tilde of user forge for our stored at helpspot.com site for, you know, for at work. This is our customer portal for they can purchase stuff. And then the current directory, because we're using Envoy and whatever, you don't need to know about that. But the directories are owned by user and group forge, and they're in the forge directory. Now, we saw before that Nginx and PHP are typically run by group and user www-data, so how do they write to files in here? They wouldn't normally be able to. So Nginx is set to run as user forge. Now, this still has a master process run as root, but it spawns the child processes, the ones accepting HTTP requests, as user forge. PHP FPM, out of the box, creates a Unix socket just like mysql. Unix socket is a faux file. It has file permissions, therefore. It has a user and group. In this case, in Forge, they aren't owned by Forge. Instead, the listening thing, PHP's Unix socket that it uses to listen for new connections is owned by www-data, but the permissions on them, the mode, do have the ugly numbers, 666, but the other part of that is set to read and write. So even though Nginx is running as user forge, it can write to the Unix socket file. It can send requests to PHP because the Unix socket file that is listening has read-write permissions on the other bit, which means anything else that's not in the user or group of that file can write to it, can read and write to it. Now, more confusingly, on the bottom, we have user and group forge. So PHP is doing two things, right? PHP FPM, specifically, is listening for new connections from Nginx on this socket file. But then it's also running PHP, and it's going to run PHP as user and group forge, right? So there's the input. Nginx is sending data to PHP FPM. It's listening on the Unix socket. And then its output is running your PHP files. And it's going to run those PHP files as user and group forge. And, not yet, Because your files in your Forge website are owned by user and group Forge, it can read and write to them, which means the storage directory that has the logs, the cache, view cache files, the other compiled stuff is fine. It just works because PHP is run as user and group Forge, and your web files are all owned as user and group Forge, and their permissions allow the user and group to read and write to them. Right? Permissions are not simple, right? It kind of sucks. If we wanted to, we can make PHP FPM listen on a TCP socket instead of a Unix socket. This avoids a little bit of the circus of permissions, because then we don't care about the permissions of the listening socket. Then Nginx can send to localhost port 9000. It doesn't matter if Nginx is running as any user at all. It can send that to PHP FPM. It doesn't matter if PHP FPM is running as any user at all because it's just listening on a TCP network, which doesn't have any of the Linux permission stuff. But we still set that PHP is run as user and group Forge, right? That's not part of the accepting new connections part. That's just how it's running PHP. So it's a complete circus of permissions. It's a little bit insane. But once you kind of get your head wrapped around it, it really helps you out so much figuring out just general issues, right? Like, why can't I write to this directory? I thought all my permissions are lined up. ACLs, and what do I have? You get to see a little extra. Oh, good, I'm over after ACLs. I'll continue. OK, ACLs, access control, whatever levels, I don't know. I haven't Googled that either. ACLs are a kind of layer on top of Linux permissions that you can do to add more permissions. So you will know that there's an ACL, a extra set of permissions, if you see this plus sign. That means in addition to the Linux permissions, there's also some ACLs on top of it that you can check out. So if I get fACL, I'll find the ACLs of a file. In this case, this root directory /var. And this is just standard. I haven't had any ACLs to this directory. It just has the user group and other kind of permissions you would expect. No defaults, nothing like that. It says the user or the owner and group is root. This is basically not telling us anything, right? It's just saying the standard Linux permissions are all that's applied to this. You would not see a plus sign on the permissions of this /var directory because there's nothing there. But we can check out if there is anything with the get fACL command. If I set some stuff, I can do it recursively. That's capital R. M, I believe, is modify. And then we set stuff. Once again, we have a comma-separated list, so there's two things. The first one is G, so I'm setting a group, separated by colon, www.data, so the group. I want the group www.data. I want the group www.data to read, write, and execute to the var www HTML directory. And that's recursively setting that for the current files that are underneath that. The D is for default, so I'm also setting defaults for new files and folders. That's really important because while under normal Linux permissions you can set a default, it's a huge pain, especially for automation. For something logging in to do some commands that's not like a user's SSH connection. Like I might log in over SSH to run commands, if that doesn't set up a shell, that doesn't set up your shell environment variables, that might not change the thing that changes the default permissions when you create a new file and directory. So if I wanted group www.data to always have read, write, and execute permissions in a certain folder, I can use these ACLs to do that. Get fACL HTML, the users group, what did I do here? I don't know. So the group here, I'm just showing you that the group www.data can read, write, and execute. We have both the current permissions of this var www HTML directory and the defaults for new files. If I wanted to, I don't have to use just groups. I can do users. So in this command, change the G to U for user, and then a username instead of a group name. And I can say, in this case, user admin and user deploy can read, write, and execute to these files and directories, both for the current direct files and directories there and also for the defaults for new files and directories created under there. So imagine a scenario where you deploy in a setup where you have to log in as user deploy or whatever you want to deploy your files. If that creates new files, new web files with your updated code, it'll probably create new files as user deploy and maybe even group deploy. But if your web stuff is running under www.data, your PHP, your Nginx, it might not be able to write to that anymore because it doesn't have a matching permission to do that. It doesn't have permission to write to those. But in this way, it would, in one of these two ways, whichever kind of way you want, user-based versus group-based. Just by default, we have those default permissions. Am I early? Let's do some questions. Whew, an hour and a half. Wow. All right, thanks. Who's got questions? You?
You mentioned earlier securing environment files. Do you have any suggestions for doing that, especially the number of sites you have rows?
No, I haven't done that. I haven't used a large-scale thing that would employ a really complex environment variable thing. So what I'm thinking there is if you use something like Docker or if you just have kind of a large number of servers, securing secrets becomes hard because every server needs to know things like MySQL connection settings, for example. In something like Envoyer, we have a .m file that is managed by Envoyer and it just adds it to each server. You might have a different setup. So let's say you have a something like console or etcd configuration. What are those called? What's the general name for these things?
Secret management.
What's that?
Secret management.
Sure. That's not what I'm thinking of, but it doesn't matter. It's basically what it is. So people are using them for service discovery and stuff like that. It's basically like a key value store, but it's distributed, works in nodes. It's redundant because you typically run it in multiple servers. You ping its API like a web request. So maybe you do something fancy like if a key changes in this configuration management thing, if in like console or etcd or whatever, automatically update a configuration file on all of these servers. So if my database password changes, I update that in this service like console or etcd, and something listening for that key to change will know that it changed and recreate configuration files like the .m file with that. Now, whether or not this is secure or how you set it up, that's a matter of doing SSL and stuff, because I don't know or think that data is stored in an encrypted way inside of those systems. Although, HashiCorp, who makes console and that kind of stuff, has another product whose name escapes me that is made for that. Vault. Anything else?
I find myself using sudo bash to avoid having to type sudo every time. Do you do that as well? Or do you...
Well, it's going to, so the question is, he uses sudo bash a lot to,
Anytime I'm going to run one.
you use sudo a lot, in other words, right?
Yeah, anytime I'm going to run root commands rather than write sudo line.
So if you use sudo for every command, it will work, but it's going to run as user and group root. So if it's making new files, those new files are going to be owned by user and group root. So imagine booting up Artisan using sudo, or newing up a new Laravel application using sudo, or just doing anything that writes to a log file. If there's a new log file created in that action and you're using sudo, the file is going to be owned by user and group root. And then, if something else needs to write to it later that's running as user or group www.data, it's not going to be able to write to it. It won't have permission to necessarily. So using sudo all the time will work for that one command, but you're setting yourself up for issues later.
Like if I'm configuring services or something, rather than type sudo for everything.
Oh, I see what you mean. I'm sorry. So yeah, you can do that. The whole point is that you need a secure way to get to the escalated user root. So if you need to install stuff or start and stop services, you need to be user root, essentially. But you use sudo for that. If you want, you can just type in sudo bash or sudo su or something that changes you to user root. And that's fine. The point is that you don't want to allow initial root login after that. If I log in as user Fideliper and I'm allowed to use sudo, I do sudo su to make myself root. I still have to put a password to make myself user root. So like you get that extra layer of security.
Yeah, more of a tip for people that don't know about it.
Right on, yeah. Sudo su, it saves you time. Don't worry about stuff. Anything else? Anyone I'm not noticing? Yep.
Yeah, so actually, we'd much rather code than manage servers all day. So as a team, is there like some hosting services, some of the floors, rather than just the base level security, we go beyond that, like non-evasive, provide some sort of DOS system level prevention as well?
I don't know of any top of my head because I think at that point you're getting into like hiring. Oh, that's not a real answer. I'm sorry. I mean, it counts. It would because it's pretty secure the way they set it up, but it's like. The answer is how much money do you have? But to really get that, you end up hiring kind of consultants or companies that do that for you. Like AWS has all these features, but you have to learn how to use them. So if you want to do AWS and set that up yourself, you kind of can get all that stuff. But again, even installing stuff in your server, going beyond what I covered, like adding SE Linux and AppArmor and that stuff, you need to find someone who knows how to do that. I don't know of any services that kind of have really advanced level of security. I'm sure they exist. I'm just not like in the enterprise sphere in my day-to-day life. And I think that's where you would find it. Yeah, Rackspace. They're fanatical support. They'll do all that kind of stuff for you. I'm sorry for picking on Heroku. It's valid. It's expensive, but I'm not sorry. Ooh, I hope you don't work at Heroku. I hope I never apply to a job there. Anyone else? Yeah.
Yeah, you had a file there that was an alternative to supervisor.
I can make my slides available. So you mean the configuration it had for systemd? Yeah, definitely. And actually, the Service for Hackers site has an example of that in a video there. And all the videos typically will have a write-up of it, so you don't have to actually go through the video, because it takes time to do that. Nope. I mean, you can go to serviceforhackers.com, find it. I won't. I was going to go and check it out, but I'll just end up showing you how terribly I type. I thought I saw someone pointing to someone over here that had a question. You're pointing. Cool. Hey.
Do you have any thoughts or feelings about like Puppet or Salt or Chef?
They're awesome. Use them. The question was, do I have any feelings about Puppet, Ansible, Salt, all that good stuff? I love Ansible. Ansible is, in my opinion, the next stage of using bash scripts to automate stuff in that it's kind of straightforward. So if you have automated stuff doing bash scripts, you're just throwing commands into a file, and then it runs them in sequence. Ansible is the next step in that, in my point of view, because it works over SSH, which is very familiar to us in general. And then you can tell it to, run commands. You're technically not telling it to run commands. You're technically telling it the state you want something to be in, and then it figures out what commands to run to do that, which is the part that lets you run an Ansible run over and over and over again without it messing stuff up like a bash script might. Like if a bash script appends stuff to the bottom of a file, every time you run it, it's going to keep appending stuff. It doesn't check to see if it's there already. Ansible and other ones will do that. Ansible is agentless, meaning you can run it from your own server and it connects over SSH to other servers and it does all that good stuff. It's so helpful to have something like that set up. When I started Service for Hackers, I left the environment variable debug set to true. Someone went to a 404 page and they saw my password for my database because I'm a professional. So I changed the password and I used Ansible to do that. Another time my server died and I had a server up in like 15 minutes to replace it because it was just kind of orchestrated. Salt is also nice. Puppet and Chef are more complex, I think. So I think Ansible would be the first one I would suggest. But if you want to jump into anything else, do whatever you want. But definitely check them out. Cool. Down here, guy, answer, go. Hi, I see you.
Are there any HHVM or engine-specific configurations that forge tweaks or scaling, not scaling?
Forge, no, I don't think so. So the question is, does Forge do anything to kind of help you scale up, I believe, in terms of Nginx configuration? Okay, so Forge kind of does the default stuff. It keeps it there. I think it might, I forget, Forge, Taylor can get more specific. I think it's kind of the default stuff, and then Forge will let you add multiple sites and all that stuff. So it's really kind of a model for the 90% use case, I think, which is just throw your stuff on there and it'll work for the most case. Forge does allow you to create a load balancer, and then it will let you distribute that amongst multiple web servers if you've set multiple Forge servers up. So that's kind of a common scale out scenario. But in terms of like really hardcore tweaking your server, it doesn't do that. I mean, and you can. I don't like going hardcore into tweaking server configuration. Having done it before, there's like a basic level of PHP FPM stuff you can do. Once again, Servers for Hackers. I have a thing on process management in PHP FPM you can check out. And you can tell it to basically set up run more processes to accept more connections. But beyond that, I don't go too hardcore because it's kind of easier to scale out with more servers. It's more expensive, of course, but easier. Is that it?
Are these slides available anywhere?
Not yet. They will be somewhere, probably slide deck. I forget whichever one's prettier.
Talking about Forge running multiple sites.
What's that?
Talking about Forge, when you are running multiple sites in one server,
Yep.
how do you manage to make it secure so one site doesn't interfere with the other site? The one site is for one client and the other site is for another client.
Okay. Are you letting those clients log in or anything?
Not to the server, but for example, they could load a PHP shell.
Yeah. Okay, so that depends. And it depends how you're using Forge. I get, like, if you're using Forge for multiple clients, I would charge the customer and then have them have their own server, because then it's totally separate. One thing you can do in terms of running your websites is you can tell PHP to run multiple resource pools, and then one website uses one resource pool and another uses the other, and they can even have different usernames. So like PHP might run as user Bob for one site and user Jane for another site. That's kind of going outside of Forge, though. Like Forge won't set that up for you, so that's configuration you might end up doing yourself. But that's not like someone logging in. That's just PHP, the website, running. I'm not sure the best way to go about what you're talking about. So the setup I think you're talking about, like having multiple clients on a server and letting them run stuff as a shell as a different user.
They don't need to log in like SSH or
Yep.
run a shell. But I mean, if one of the clients gets a little smart and wants to load a PHP file and manages to run it like a PHP shell,
Yeah.
how can you like keep them contained? I think that the stuff you said about PHP running as a different user might apply to that.
Yeah, it would. Yes, that makes sense. So like this is like a very typical WordPress attack vector where someone uploads a file that can somehow get executed as PHP. And then that file is run as like a web request because then it exists on the server, and it can be, and then it might run like the exec command that runs a command on the server. It'll get run as the user in that instance that PHP is run as. Yeah, that thing. But that's hard. I've done it and it sucks. chroot. You can kind of contain, if you set up chroot in PHP FPM, you can contain it and tell PHP that its entire universe is just this one directory. It doesn't have access to other stuff in the server. The problem with that is that it means it doesn't have access to underlying things, in my experience. Someone might know better. Yeah, you have to share stuff like underlying C libraries so it can make a curl request or connect and have SSL libraries and OpenSSL available to it and all this kind of garbage that's under the hood in a Linux server.
I think Cloud Linux is kind of taking some of the pain away and started.
No, I don't know, Cloud Linux.
cPanel
Yeah, okay,
back that I guess they kind of got better.
cool.
You could run a VPS and have them kind of
Yeah, and actually cPanel and WHM, even them, does a good job of separating that stuff out. Tries to, yeah, exactly. It's also not fun.
Do you have any favorite tools for like analyzing logs or keeping track of malicious behavior?
So what I showed here is the logging thing I've used. I mean, there's like SAS logging things you can use. And then it's a matter of, so the question is, what favorite tools do I have for logging and auditing and that kind of thing? What I showed you, the elk stash is really nice because there's a lot of tools available to consume log files and other sources of data, throw them into Elasticsearch, and then use Kibana, which is like the web front end to see stuff. Like AWS has a hosted Elasticsearch and Kibana thing you can use. There's a SAS version of the elk stack that Elastic.co makes. And there's a ton of logging tool, like SAS-based ones. They're all kind of expensive, but you can find them. I like the elk stack, and I like how Kibana lets you filter stuff in really useful ways. Like a company out of San Antonio, where I live, the USAA, logs every packet going in and out of their network, which is like hundreds and thousands of computers. That all gets logged to an elk stash, and then they have people monitoring that for weird source destination traffic to see if traffic is going somewhere it shouldn't. And it's crazy. They have like huge clusters of data because it's logging every packet. Cool. I'm out of time. I'm sorry. I just realized I was looking this out. Thank you.